and welcome to Chapter 2. This chapter is going to concentrate on getting us started with Spring-MVC. And we're going to start by configuring our development environment and the web server that we'll be using for this course, Apache Tomcat. Now, you can use any development environment or web server that you're comfortable with, but I'm going to use Eclipse for this course. We're going to follow a few basic steps to get the environment configured, but you don't have to use exactly the same setup as me. If you've done some web development in Java before, then feel free to use your own setup. And similarly, although I'm assuming you have some previous knowledge of Java web development before, you might need a recap of the concepts of MVC. If so, then in the second half of this chapter, I'll be spending about 10 minutes having a look at what MVC means. Now, if you've been on a virtual pair programmers course before, you'll know the routine for the practical work by now. But if not, you can use any development environment you like. That can be Eclipse, NetBeans, IntelliJ, or even a basic text editor. As Eclipse is probably still the leading IDE, I'll be using that one for the recordings. Feel free to substitute your own. Now, I'm assuming a previous knowledge of Java web development and Spring, so I'm working on the assumption that you already have an IDE configured and working, and that you're comfortable with it. Now, I will need to show you the code we're going to be using through these videos. On the previous Spring Framework course, I worked through a very simple bookstore as an example, and I'll be continuing working with that code. Let's have a quick run down the code that I'll be using. Have a look in the src folder. I'll just make that a little wider. And there are 4 packages in there. There is a client package, and inside there we have a very simple main method just to use as an informal test. In there, we're opening the application context and we're doing various operations with our services. The data package is pretty much empty. And that's because on this course, to keep things focused on the web tier, I'm only going to be using mock implementations. In other words, all the data I'm using will be in memory. This is so that our code runs fast and so that we're not going to run into any problems with databases and Hibernate and so on. Now, of course, with your Spring knowledge, you can edit the XML application context to switch in a production database if you prefer. The domain tier is similarly simple. There's just a single class in there called book, and that naturally represents a book that you could buy from an online bookstore. There is a test class in there, but that's not really very interesting for this course. And finally, and perhaps most importantly, here's the services package. And we do have 2 services defined in here, but really for this course, I'm only going to be interested in the book service. So here's its interface, and very simple and basic. We're able to get all the books by a particular author, get all the recommended books for a particular user, and find various books and add books and so on. Of course, in a real application, this interface would be far richer. As I mentioned, we're only using mocks for this course, so have a look inside the book service mock implementation, and there are a series of, I'll just go to the bottom of here, there's a series of full implementations of those methods. We're going to want some fairly rich web pages later on in the course, so to keep things interesting, I've added something like 1,000 books inside this mock implementation. Before we build any web pages, we can go into our Spring client and run as Java application, and the red text is just the Spring logging, but the rest of it you can see from the top. Here's our entire catalogue, and there's a full list of all of the books in our catalogue, which looks quite good. And then going down to the bottom, I think in the client application, I just add a couple of my own books And there we are. We've added Spring in Action by Craig Walls, Expert One-on-One J2EE Design and Development by Rod Johnson, and then we do a couple of searches by ISBN. Okay, so that's it for the Java. I'm also assuming you have a good working knowledge of Java web development. If not, do consider picking up our course Java Web Development. As mentioned in the introduction chapter, I'll be assuming that you do know about JSP, JSTL, and servlets. You don't need to be an expert in these concepts, but you at least need to recognize them. Okay, well, for this course, I'm going to be deploying to Apache Tomcat. Also, I'm going to use a very simple process for deploying to Tomcat. Now, I can probably use an IDE to automate many of the Tomcat operations for me. As I've said though, I don't know exactly which IDE you're using, so for the videos I'll be keeping things as simple and basic as possible. You can follow my approach if you're following along at home, or if you'd rather use an Eclipse plugin, feel free to do so. I just can't support you in that. To start, we're going to need to get Tomcat up and running. Now, as I mentioned, I'll be doing this outside of the IDE. Inside the workspace that you've downloaded as part of this course, you'll notice that I've supplied a Tomcat folder. This is a full distribution of Apache Tomcat 6. For simplicity, I've also supplied a bat file called starttomcat.bat, and all you need to do is double-click to run it. Now, by the way, if you're running on Unix, Linux or Macintosh, you will need to look inside the Tomcat bin directory and you'll find a startup shell script, startup.sh, and you can run that through your terminal. Now, what you're looking for when you've started up Tomcat is what I call a clean console. It's quite hard to explain really because, as you can see here, there's an awful lot of rubbish spat out by Tomcat that I'm really not interested in. It's largely info logging. We're really just looking for anything like Java stack traces. Any exceptions thrown means that something's badly wrong. We're looking for the line server startup, and that should mean all is well. Now, to check that's working, you'll need to go to a browser, and any decent browser will do. You can also use Internet Explorer if you like on this course. And what you're going to do is navigate to the address 127.0.0.1:8080. And then hitting return, you should see the Apache Tomcat congratulations page. Okay, so back into Eclipse, we're going to deploy our code on this course using Ant. Now, the Ant script you'll find in the root of your project. It's the file called build.xml. I don't know if you've used Ant in the past, and that's certainly not a prerequisite of this course. You won't need to do much with Ant. This script I've provided here is responsible for gathering together your project and to build a WAR file in the correct format. For example, all of the XML files, such as our application.xml, will end up under the webinf directory to ensure that users can't browse to them. Again, if you're in any doubt about WAR files, do check our standard Java Web Development course. Now, to run the Ant script, you need to right-click on it, select Run As, and Ant Build. Now, there is a problem with Ant if you're running in Eclipse and you haven't run Ant before. You might see this error here, build failed. And if it's saying that Java Home does not point to the JDK, then this is because, by default, Eclipse uses its own runtime, and this won't be capable of running Ant. So if you do get this error, then you need to download Java from java.sun.com. That's the Java Development Kit. Install it, and then we'll need to configure Eclipse to use this version of Java. To do so, we go to Window, Preferences, and then find Java, expand the branch there, and we're looking for installed JREs. Now the default implementation of Eclipse will just have a Java Runtime Edition installed. We need to click on Add, Standard Virtual Machine, click Next, and then for JRE Home, we'll click on the Directory button and then simply browse to wherever you installed your Java development kit. And at the time of recording, the default installation is under Program Files, Java, and you must select a folder beginning JDK and not JRE. I've gone here for JDK 1.6. So we click OK there, we click Finish there, and then we just need to switch the checkbox to our new JDK. I'm sorry about that, that's a little tedious and it won't have affected all of you, but just in case, we have had a lot of support requests in the past over that issue. So in future when you need to rerun the build, you can just click this button here, which I think is a little toolkit. It's not a very good icon, but it's got a red toolbox alongside a play button, and that will rerun the Ant build. And what we're looking for with the Ant build is for the compile to go through successfully, as you saw there, and it should end up build complete and build successful. Now when the WAR file is built, the file is copied to the Tomcat web apps directory, and as long as Tomcat is running, the application will be automatically deployed. Here's my Tomcat console that you saw earlier, and just while I was talking then, after the build ran, in fact, a lot of logging has been output to the console. Let me rerun that build again just so you can see what happens. So the build script's running now. There's the console. And there you can see lots of logging appearing on the console. And once again, what we're looking for here is no exceptions, no crashes, nothing nasty appearing in the console. There's a lot of logging here, and in fact this is Spring telling me that the Spring container is automatically being loaded. One thing to be careful of here is that Tomcat polls for new deployments every 2 seconds or so be careful not to be too impatient. You should also check the console every time you run the build to make sure there are no stack traces. Now we need to test that this application has deployed successfully, and you might notice that inside my web folder there's a collection of JSP files that we'll be using throughout this course, but one of them is a quick test. It's just test.html, a very simple HTML file, and I want to make sure that we can see this through our browser. Now you'll notice in the build file, the WAR file that we've been creating has been called mywebapp.war, and Tomcat will create an application under the context name of mywebapp. So back in our browser, assuming you've got the Tomcat congratulations page, you'll need to browse to mywebapp, that was the name of the WAR file, / and then the name of the HTML file that we want to browse to. And all being well, you'll get the hello world message. If you've got this far, then your environment's fully configured and we're ready to start the course. I'm assuming that you're already familiar with a basic knowledge of MVC, or Model View Controller. If not, then I strongly recommend our previous Java web development course before you tackle Spring-MVC. I promise that will be the last plug I make for the Java web course. Just in case you're a little bit rusty on MVC, I'm going to do a quick recap. If you're very familiar with MVC already, you can safely skip the rest of this chapter, and when you rejoin me in the next chapter, we'll be actually using Spring's implementation of MVC. If you're still with me, recall that servlets are regular Java classes that are capable of being mapped to URLs. Now we use the standard web.xml file to map a URL to a particular servlet, And once we've deployed our web application, the servlet can respond to requests from browsers. The original idea behind servlets was that they would generate dynamic web pages. But this idea really failed because embedding HTML inside Java code turned out to be a very poor strategy. Now, maybe very trivial web applications could do it, but I'm sure you're not working on trivial applications. So JSP, or Java Server Pages, were invented to allow for dynamic web pages by embedding the Java into the middle of regular HTML. Now, this also looked really attractive at first, but it also failed as a workable idea because you then end up with massive unmaintainable scripts containing a twisted mess of logic and presentation. JSPs with Java logic inside them are a nightmare to debug, and code just generally doesn't sit well in the middle of HTML markup. So the Java community began to realize that both servlets and JSPs could be used in combination. On receiving a request, the servlet can parse the input parameters, and in this case, it's the details of a book. And then the servlet can call the regular Java logic using these input parameters. Oh, and by the way, if we're working on a Spring system, as we are on this course, that Java logic would probably be a Spring service class. Now, servlets are really good at doing all of this because they are regular Java classes and therefore good at calling other Java logic. Now, once the Java logic is complete and the processing for the whole request is complete, instead of the Java servlet outputting the result page, which is how servlets originally worked, in fact, the Java servlet passes control over to a JSP. Then what happens is the JSP, probably in combination with the Java standard tag library, can handle the work of presenting the results. It's important to remember that JSP isn't doing any of the calculation work. It's certainly never going to call a database or a Spring service or anything like that. It's just passively taking the results from the pre-processing and then outputting the results. And the code we're looking at here is from the Java Web Development course and is a genuine production standard JSP implementation. And notice it looks quite clean and simple. Now, this way of dividing a web application into three logical tiers is often called model view control. The M represents the model tier. Now, that's just our regular Java logic. This is the code that has no reference to web applications at all. Now, we could reuse this logic in non-web applications. In fact, in our case, the M is going to be all of the services that we built on the previous Spring Fundamentals course. We won't need to change that code at all. The letter V represents the view. Now, this is just the presentation. In the case of a web application, this will be a dynamic web page. And for at least the first half of this course, I'm going to assume that this is JSP, Java Server Pages. But it could be a PDF file, an Excel spreadsheet, or maybe some other Java web technology, and we'll be looking at a few of those later on in the course. The C of MVC is perhaps the most interesting of the three tiers. This is the code that handles the incoming web request, forwards it to the correct model code, and once the logic is complete, the correct web page to forward to is selected. For this reason, it's called the controller. Without the controller, there'd be nowhere where we could extract the incoming web parameters, and there would be nowhere to put the logic to forward to the results page. Now, we could write the controller using a simple servlet. and we call this servlet-based MVC. Now, as we mentioned on the Java web course, for small projects you certainly could use the servlet-based MVC style. I find it hard to define what I mean by a small project. I do mean a non-trivial project, but probably a project with, say, 10 or fewer use cases. When you go beyond that kind of level, I do find that writing servlets by hand becomes rather overwhelming. So most professional projects in the field tend to remove the servlets altogether and use some kind of framework. And before we look at the common frameworks that are used, I should really justify why it's not really viable to write your own applications using handwritten servlets. First of all, servlets are fairly tedious to write. You have to extend HTTP servlet, you have to follow a very rigid structure in your servlet, and probably worst of all, you have to configure them in web.xml. If you've been through that pain, you'll know what I mean. There's a lot of copy and paste code inside the servlet. In particular, the boilerplate code down at the bottom of the servlet where we're forwarding to the correct web page. The JSP file name has also got to be coded into the servlet. Now, of course, you could externalize that into a properties file, but that's just more tedium. And finally, and almost certainly most importantly of all, validation is very tedious to do. In the servlet, you would have to check that all of the parameters, the incoming parameters, have been filled in properly. And if they haven't, you would have to hand code the logic to redirect back to the original page you started from. And you would have to ensure that all of the fields in the form are correctly preserved. Very tedious to do. So that's why most professional Java web projects use some kind of framework. Now, just before we get on to Spring, I'll just very quickly mention the big frameworks in the field. There's Apache Struts, which has been around for years now and was probably the first web framework to make it big in Java. It's rather dated and hasn't really been aggressively modified down the years, so it's not much fun to use, to be honest, but it is really heavily used. It's perhaps to this day still the leading web development framework. Now, there is an official standard in Java, that's Java Server Faces. Now, JSF does have its fans, but some people find, and at Virtual Pair Programmers we've found the same, that it is rather awkward to use. However, that's JSF 1, and at the time of recording, JSF 2 has now become live, and JSF 2 is certainly a vast improvement over the original JSF. However, we're here for Spring-MVC, and probably the biggest advantage of Spring-MVC is that it integrates brilliantly with Spring. You're going to see in the next chapter that calling services from our controllers, which is the most important thing we need to do, is effortlessly simple. Now, a big problem in the Java web development world is there are well over 100 of these frameworks. Don't worry, I won't go on any longer. These are probably the big three at the moment, and I'm sure you're going to find many others as you go through your career. Anyway, that's it for the basic theory behind MVC. I hope you have a reasonable grasp of what MVC is all about, because in the next chapter we're going to start getting busy with Spring's implementation of MVC. So the main job we've done in this chapter is to set up a basic development environment. I hope you haven't had any problems, but if you have, do contact us and we'll be glad to help, because you can't go any further on this course unless you have a working environment. Now, MVC is a long-standing concept where we divide the application into three logical areas. M is for model, and that's the bulk of the business logic. The V is for view and denotes the presentation. For most of this course, we'll assume that's just JSP. It is good practice to make sure that there's no calculations and no business logic, as it doesn't fit well there and it becomes hard to reuse in non-web applications. The C is for control. That's the glue between the two layers. This tier handles incoming requests from browsers, it parses any incoming parameters and forwards them to the correct model code. The controller also completes the task by forwarding to the correct view. You can do all of this by hand using just servlets and JSP, but it isn't much fun on a real project. Okay, so that's the basics. In the next chapter, it's time for the first serious work, where we'll see how you can do all of this in Spring-MVC. Have a good break. I'll see you in chapter 3.